Hello, geometry students. This is 10-6. I taught this in class, but some of you requested a video, so I am making this video for you. Our quiz is going to be Tuesday the 13th. So you need to write down this theorem in your packet. If two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So that is what we want to highlight here. 1/2 the sum of the arcs intercepted by the angle and the vertical angle. And you can write down this too if you want to. So here's an example using this theorem. We want to find x here. And so in order to do that, we need to find the intercepted arc. So we have 130 and the vertical angle, which is 84. So it's going to be 1/2 130 plus 84. So go ahead and see if you can find out what this answer is. It looks like we're going to have x equals 1/2 of 214 and x will equal 107. Let's try into some other examples that you will see on this quiz. Here we want to find x. However, if you notice, we don't know this arc and we don't know this arc here. So therefore we can't find x directly, but we can find e. And then if you notice, e and x are supplementary. Okay, so let's find e and then know that e and x are supplementary. So my work here shows that we have 1/2 of 218 when we add those together. We're finding angle e. So angle e then is going to be 109. I'm getting ahead of myself here. So angle e is 109. So since we know that e and x are supplementary, we can take 180 minus 109 and we are going to get 71. So x equals 71. Now let's try this other example in which we find x and it is an arc. So here's our angle and we have 110 equals 1/2 x plus 97. So go ahead and pause the video and see if you can solve for this variable. You should have got x equals 123. We times by 2 on both sides and get 220 because we want to get rid of that fraction first, and then we subtract 97 from both sides and we get x equals 123. All right, the next theorem. Go ahead and pause the video and write this down. This theorem is just telling us about a secant and a tangent that intersect on the point of tangency. We have actually seen this before when we have an angle on the circle, inscribed on the circle. It's always just going to be 1/2 of the arc. So we've seen this before. Now it's just being a little bit more specific about what type of lines we have, a secant and a tangent, and where it meets at the point of tangency. So not too new to us. If we want to find QPR, we want to find this angle right here. We're going to take, this will be 1/2 of 148. And 1/2 of 48 is going to be 74. So the measure of angle QPR equals 74. So nothing new here. Here's another example in which we have to find the arc of DEF. We can go ahead and find the arc DF right here. And pause the video and write this example down. We did this in class on the worksheets and we had some troubles with it. So DF is going to be 128. So now we have to figure out what this piece is right here. So we take 360 minus 128 and we're going to get 272. So that would be the arc DEF. It's going to be 272. So that's a two-step process. Okay, here's the next theorem. Go ahead and pause the video and write this down. What this theorem is saying is if you have two secant lines, a secant and a tangent, or two tangents, that's on the exterior of the circle, they meet on the exterior. So if you have an angle on the outside of the circle, it's going to be 1/2 the difference. And I highlighted that because we need to remember that. It's going to be 1/2 the difference of the measures of the intercepted arcs. So here is an example where we have to find angle L. Pause the video and draw this example down. All right, so this is an exterior angle on the circle. So it's two tangent lines because we have 2 points of tangency. So angle L is going to be 1/2 of the difference of the intercepted arcs. So we don't know this bigger one, but we can definitely find it taking 360. This right here would be 360 minus 102. And that ends up being 156. So now we can go ahead and, oh, excuse me, I'm getting ahead of myself again. I'm giving away the answers. Minus 152 is going to be 258. All right, so this arc right here is going to be 258. So what we can do is take 258 minus 102 and take 1/2 of that. So angle L is going to be 1/2 of 156. And then so angle L will be 1/2 of 156 is going to be 78. So that's how you would do that problem. The next problem, we can set it up. Now this is a secant and a tangent. Still same setup though, 1/2 the difference because this A is on the outside of the circle. So we have 56 minus or equals 1/2 of this arc. We don't know, I'll label X. X minus 95. So we're going to solve this equation. Why don't you pause the video and see if you can do this by yourself. So I went ahead and times by 2 here, and I got 112, and then I added 95 to both sides because that's the opposite of subtracting 95. So that's how you would do or use the theorem when the angle is on the outside of the circle. So now here's a little chart that we're going to put together, and you could feel free to put this in your packet on the back side where there's that big open space after chapter 11. On the circle, anytime your angle is on a circle, it's always going to be 1/2 of the arc. Inside the circle, if we look back at our theorems, it's going to be 1/2 the sum of the arcs. And then outside the circle, it's going to be 1/2 of the difference. So make sure you write this in your packets, probably at the very back of your packet after chapter 11. This will be very helpful on that quiz. And I'll see you guys tomorrow. Hope you had a good weekend. Bye-bye.